Welcome to the basic Arduino Basic project, and today we will learning about LCD based sensor monitoring system. And here is the agenda, overview, components, principle and procedure. So in this tutorial we will study how to monitor temperature using an temperature sensor and display the readings on an LCD screen with Arduino. We will learn to read analog temperature data, convert it to Celsius and Fahrenheit, and show real-time temperature values on a 16:2 LCD display. The required components are Arduino, temperature sensor, LCD and jumper wires. So in this sensor monitoring system, we are using temperature sensor. It will continuously measures environmental temperature and outputs a proportional voltage signal. The Arduino microcontroller reads this analog signal, processes it and converts it into meaningful temperature values. And these processed readings are then sent to the LCD display through parallel communication. The LCD acts as a visual interface. It will display real-time sensor data in human readable format, allowing users to monitor temperature condition at a glance. The system updates continuously, providing instant feedback on environmental changes. And next is the procedure. We need to build the circuit, program, then compile the program and upload to the Arduino Uno. So open Tinkercad. Then we need to first we need to log in, create circuits, then we need to search the components. So the required components are LCD and temperature sensor, Arduino Uno, then breadboard. Here breadboard is required. So Arduino Uno, search, then breadboard, then LCD 16:2. I am not taking this LCD I2C. We can take that also. Then temperature sensor. So TMP is there, right? Yeah, this one. So now we need to make the connection. So I will keep this. You can keep this here. Yeah, now positive rail is there, right? You can consider from this, okay? And this one I will keep here. Or do one thing. Yeah, this pin is connected, right? Or connect like this. Yeah. So now pin number 1, so this one, yeah, this is connected to the ground. So I will directly connect this to ground. So black, yeah, and VCC, this is VCC, right? So power, that is connected to the positive rail, that is red. Next V out. So here I am connecting this to pot. So this is pot. So I am taking this to here. Yeah. So this is connected to the pot, middle of the pot. So I am taking this on orange color, and Other two pins of pot should be connected to the 5 volt and this. You can take it here also, 5 volt and ground. And next RS, it should be connected to the D12. You just connect like this. D12. Yeah, it's not showing connection. Next RW is connected to ground, so this negative rail, and next this is connected to the, so pin number 11. Yeah. And next D4, this is D4, right? So it should be connected to here digital pin 5, and this should be connected to digital pin 4, and this 6 is connected to digital pin 3, and this 7 is connected to digital pin 2. Yeah. Now this anode and cathode is there, right? So anode is connected to positive rail, cathode is connected to the negative rail. So this sensor, so this is power, right? So it should be connected to the positive rail, and this is ground, it should be connected to the negative rail. Yeah, here this is positive rail and it should be connected to the negative rail, and this is pot positive, right? So, and this is negative. Here this is pin, and this one is connected to the negative rail, right? Ground. This is negative rail, positive rail, anode, right? Red color, and this cathode is ground. So this connection over. Now VCC output is this output is connected to the A0. So this is A0. I connected this to the analog pin. The connection is over now. Now we need to one thing is pending. So for this you can see here we need to connect using resistor for this one. Search resistor, this resistor, so 220 ohm resistor you need to take. This is power pin, right? Yeah. One thing I forgot. Means we need to connect this to the power. This one, right? Yeah, here I will connect this to the power, and also it should be connected to this also, right? This is positive. Yeah. Now similarly we need to connect the ground. So this black should be connected to ground, and even this should be connected to ground. Now connection is done. We need to write the code. Blocks text continue. So first we need to declare the pin values. Then we need to write the working. First hash. So here we having LCD, right? So hash include LCD liquid crystal dot h. Yeah, hash include liquid crystal dot h. So now we need to declare the pin liquid crystal LCD of pin is 12, 11, 5, 4, 3, 2. Pin declaration is over. Now variable declaration const int sensor. So sensor is connected to A0, right? So here you need to write A0. So this is the analog pin. Next we need to declare float. Float is the data type. Temp C. I just write it as temp C, means variable to store temperature in degree Celsius. So why float? Why not int? Means int is a whole number. So here in float we can consider decimal number also. So I am considering here float v out. So we have temporary variable to hold sensor reading. Then while setup. So here we need to write sensor. Sensor is input or output? Input, isn't it? LCD is output. So yeah, serial begin of 9600. Okay, in the previous project I forgot to show the serial monitor values. So you can see here serial monitor values. Okay, so LCD begin of 16,2. So delay is 500. Yeah, now we need to write the loop. So here we considering V out. So V out is the analog read of sensor. Analog read of sensor. So why analog means here we connected this to the analog pin, right? If we connected this to the digital pin, then we need to write the digital read. So V out into 500 divided by, so this is the V out value formula. So next temp C means temperature in Celsius. So storing value in degree Celsius. So temp F equals to V out into 1.8 plus 32. So this is the standard formula. Okay, converting to Fahrenheit. Temp F equals to V out into 1.9 plus 32. And this is the Celsius formula. Okay, temp C equals to V out into 500 divided by 1023. This is also standard formula. So now LCD. So now we need to set the cursor, right? Set cursor. So 0, 0 followed by semicolon. Then we need to print. So to print we need to use this lines, LCD print. So in degree Celsius, so followed by this, closing bracket, then semicolon, LCD print of here we need to store temperature in Celsius. Then we need to set cursor, LCD set cursor. So based on this cursor it will set, means whether it is which position it should show, like that. So LCD print. So here we need to print in Fahrenheit, right? Fahrenheit. Equals to close bracket, semicolon. Now LCD print temp F. So if you write inside the quotes, then it will print same as it is. If you write like this without quote, it will print the value of this. The value of temp C here we will get, right? Here. So this value is showing here. Okay, so this is temp. Now we need to consider some delay. So delay is 1000. Yeah, this 1000 means 1 second. Now start simulation. Let's check any error. So temp C was not declared in the scope. So yeah, one is this one. This is done. Temp C is not declared in the scope. Suggested alternative temp F. Why? Because here I written small letter C, but here capital letter. So this is case sensitive, isn't it? Yeah, let's see the output. So it will show, right, the value. Vary the pot. Yeah, now we got the value. So in degree Celsius 74.7, in Fahrenheit it is 1. So you can vary temperature and you will get the according value of the Fahrenheit. So this is about the LCD based sensor monitoring system. For more project, please watch the upcoming videos. Thank you all.